Hi, in this video, we are going to look at another calculus problem. So let's get started. If f of x is equal to integral of 0 to x of mod of t minus 1 dt, where 0 is less than x less than equal to 2, then we have to select the correct options. First option is range of f of x is 0 to 1. Second option is f of x is differentiable. F of x is differentiable at x is equal to 1. Third option says f dash x is equal to cos inverse x. This equation has two real roots. And finally, fourth option is f dash of half is equal to half. So these are our options. And now we have to figure out how to work out this integral, right? Here, understand that the values of x are anything between 0 to 2, right? So we have to think about how that affects the integral. And the integral is over a variable t, and the variable t, it is integral of mod of t, t minus 1, where obviously the value of the modulus will change sign when you have t minus 1 above 1 or below 1. This is your graph of mod of t minus 1, and this is the point 1. This is the point 0, this is the point 2, and these are values of t, right? Now, if t values are bigger than 1, you have t minus 1 when it comes out of the modulus. Otherwise, you have 1 minus t here, right? If t values are lying in 0 to 1 range, correct? So now here the integral is over the variable t, but the variable t itself could be anything from 0 to x, right? We don't know the range of x. That's the issue here, right? So what we will do is we'll take two cases. Case 1 is when x goes from 0 to 1, right? If x goes from 0 to 1, 0 to x mod of t minus 1 dt. Think about it. The lower limit is 0, upper limit is x. And those are the lower and upper limits of the variable t, right? And we know that x itself is less than 1. So that means t is less than 1. Because t is less than equal to x, right? So t itself is less than 1 for this case. So in that case, the modulus will open with a negative sign, and it will be 1 minus t dt from 0 to x, right? And this integral you can evaluate. It will be t minus t square by 2 from 0 to x, and you'll get basically x minus x square by 2 after calculating the integral. So what we have figured out here is if x lies between 0 to 1, the function is equal to this. Because in that case, the modulus is going to be 1 minus t. Because the upper limit of t is x, but x is less than equal to 1. So therefore, the modulus is always going to be 1 minus t, right? So we have solved case 1 here for the function. Case 1 is 0 is less than x is less than equal to 1. And function f of x is coming out to be x minus x squared by 2. Because mod of t minus 1 will be 1 minus t in this region, right? Now we go to case 2. And in case 2, x is between 1 to 2, right? 1 is less than x is less than equal to 2. And f of x was given as integral of 0 to x mod of t minus 1 dt, right? So the value of t can go from 0 to x, but x itself is bigger than 1. So we should be able to split the integral from 0 to 1 and then 1 to x, right? This is the integral over some function of t, but I am splitting the integral into two parts because this function changes its behavior across the point 1, right? So this will look like 0 to 1, 1 minus t dt, because here the values of t are less than 1, plus 1 to x of t minus 1 dt, right? And now let's calculate this integral. It is t minus t square by 2 from 0 to 1 plus t square by 2 minus t from 1 to x, right? So this becomes basically 1 minus 1 by 2 from here. So 1 by 2 overall. So you have 1 by 2 plus, when you put x here, x square by 2 minus x minus 1 by 2 plus 1, right? So this gets cancelled, 1 by 2 and minus 1 by 2, and you get 1 plus x square by 2 minus x. That becomes your function in the second case, right? So now I have a full definition of the function. The function is defined like this: fx is equal to x square by 2 minus x for 0 less than x is less than equal to 1, and it is x square by 2 minus x. Okay, I have made a mistake in writing the first function. That was x minus x square by 2 here. Because it was 1 minus t, so integral was x minus x square by 2. And this side it is 0 plus, it is x square by 2 minus x plus 1 here, when it is 1 is less than x less than equal to 2, right? And now we can easily figure out the options. You can see that f dash x would be 1 minus 1 minus x for 0 less than x is less than equal to 1, and x minus 1 for 1 less than x less than equal to 2, right? After differentiating. So notice that f dash 1 is going to be 0 from both sides. Both sides. So the value of the derivative is becoming 0 on the left-hand derivative side also, and also on the right-hand derivative side. So we can say that f of x, f dash 1 exists and is equal to 0. Therefore, f of x is differentiable at x is equal to 0, right? That follows from here. Also, you should realize that when you have f dash x is equal to 1 minus x, it is going to be positive for x less than 1, and x minus 1 is also positive for 1 less than x is less than equal to 2. So the function fx is always increasing in the range 0 to 2. Why? Because the derivative is always positive in this range. So if it is always increasing in this range, then the smallest value will be the first point at 0. F of 0 is equal to 0 is your minima, and f of 1 or f of 2 is equal to 4 by 2 minus 2 plus 1 is equal to 1 is your maxima. So the range of the function is going to be 0 to 1, right? This becomes your range. So that means option A is also correct. Also, option D is easy to check. Option D is f dash of half. So that is going to be from 1 minus x, you'll put half, you'll get 1 minus half or half. So option D is also correct. And then finally, you have to see whether option C is correct or not. Now, option C is saying how many roots are there for the equation f dash x is equal to cos inverse x, right? Now, f dash x is a linear function. It's a straight line graph. And cos inverse graph, you know, it will be something like this. There cannot be two real roots. There will be only one root. Because cos inverse graph will be a decreasing function, and 1 minus x or x minus 1 graph would be a increasing or a decreasing function, a straight line, which will cut it only once. So by drawing the graph of the two functions, f dash x and cos inverse x, you can figure out that there is only one point of intersection, and therefore there are no two real roots. So the answer for this question becomes your A, B, and D. And that solves this problem. That's it for this video. I'll see you next time.